Foundation construction drawings. Hello everyone. Welcome to the classroom of Architectural Drawing and Reading, where we continue to learn about foundation construction drawings and floor structural layout drawings. The foundation is the component below the ground level of a building that bears the entire load of the building. The foundation slab is transferred to the ground, and the foundation is an important part of the building. The foundation is the soil or rock layer below the foundation that bears the weight of the entire building, transmitted by the foundation. The foundation can adopt different structural forms and select different materials. Common foundation forms include strip foundation and independent foundation. According to different materials, they can be divided into masonry foundation, concrete foundation, rubble foundation, and reinforced concrete foundation. First, foundation plan. Origin. Hypothetically using a horizontal to cut the entire building along the indoor ground floor of the building, and after removing the above-mentioned building and foundation backfill, a horizontal projection is made to obtain the foundation plan. Content mainly represents the planar layout of the foundation and the relationships between walls, columns, and axes. Function: a basis for laying lime lines, excavating foundation pits, and constructing foundations. During foundation construction, foundation construction drawings represent the planar layout and detailed structure of the foundation part below the indoor ground level of a building. They serve as a basis for laying lime lines, excavating foundation pits, and constructing foundations during foundation construction. Foundation construction drawings generally include foundation plans, detailed foundation drawings, detailed sectional foundation drawings, and written explanations. Secondly, detailed foundation drawings. Detailed foundation drawings express the sectional shape, size, material, structure, and depth of foundation burial of each part of the foundation, as shown in the figure. Common foundations include strip foundations and independent foundations. Floor structural layout drawings. Floor structural layout drawings primarily indicate the layout of beams, slabs, columns, walls, door and window lintels, and ring beams below the floor level on each floor, as well as the construction and reinforcement details of cast-in-place slabs. They serve as a construction basis for on-site installation of components or fabrication of components. For floor structures, the floor structural plan layout is an imaginary horizontal projection made after cutting the roof vertically along the floor level with a horizontal plane, various beams, and slab components on the floor are indicated by symbols and numbers as specified in the standard for architectural structural drawing. Invisible walls and beams below the standard slab are represented by medium dashed lines. For multi-story buildings, separate drawings are generally required for each floor. However, if the types, sizes, quantities, and layouts of components on each floor are identical, Only a standard floor structural plan can be drawn. If the plan is symmetrical, a symmetrical drawing method can be used. Stairwells or elevator shafts, which have separate detailed drawings, can be represented on the structural plan with a crossed diagonal line. For cast-in-place reinforced concrete slabs, their reinforcement details are typically represented by a single plan view, as shown in the figure. A cast-in-place reinforced concrete slab with bidirectional reinforcement. In the figure, reinforcement bars 1 and 2 are structural reinforcement at the supports, with a diameter of 8 mm and a spacing of 200 mm each. They are arranged in the upper layer of the slab, with 90 degrees hooks bending downwards. Bending downwards or to the right on the plan view indicates the steel bars is located on the top layer, with downward hooks. Reinforcement bars 3 and 4 are grade I reinforcement bars, with semicircular hooks bent upwards at both ends. The diameter of reinforcement bar 3 is 8 mm, and the spacing is 200 mm. The diameter of reinforcement bar 4 is 6 mm, and the spacing is 150 mm. Bending upwards or to the left on the plan view indicates that the steel bar is located at the bottom layer, with upward hooks. If it is a cast-in-place reinforced concrete one-way slab, traditionally, the distribution reinforcement is not drawn in the reinforcement plan view. The reason is that the distribution reinforcement is generally straight reinforcement, and its main function is to fix the positions of the main stressed reinforcement and the structural reinforcement. It does not need to be calculated and can be placed according to the specific situation during construction, generally Phi 4-Phi 6 at 250 to 300. For prefabricated reinforced concrete floor slabs, its content generally includes structural plan drawings, detailed drawings of joints, component statistical tables, and written explanations. The plan drawings mainly show the positions, quantities, and connection methods of prefabricated beams, slabs, and other components. The scale of the floor structural plan layout is usually the same as that of the architectural plan, generally drawn at a scale of 1 to 100. The drawing steps are basically the same as those for the architectural plan. Medium solid lines are used to represent the contour lines of cut or visible components. Medium dashed lines are used for the contour lines of invisible components. Thick dotted lines represent the center lines of beams, and door and window openings are generally not drawn. The drawing should include axial dimensions and total dimensions consistent with the architectural plan. 3. Reinforced concrete component detail drawings. Reinforced concrete component detail drawings generally include formwork drawings, reinforcement drawings, embedded part detail drawings, and steel bars diagrams. Reinforcement drawings include elevation drawings, sectional drawings, and steel bars detail drawings. They mainly show the reinforcement arrangement inside the components and are the main drawings. Elevation drawings and sectional drawings mainly show The reinforcement arrangement situation. The contour lines are drawn with thin solid lines. In the elevation drawings, steel bars is represented by thick solid lines. In the sectional drawings, the cross-sections of the steel bars are indicated by black dots. Stirrups are represented by medium solid lines, and material patterns are not drawn inside the contours. Formwork drawings are used for components with complex shapes and structures, facilitating the fabrication and installation of the formwork. This concludes the content of this section. Thank you for watching.